been through a couple of shipwrecks, so glad it's over.
Hello everyone and welcome to DataStax Monday Learning. We are happy to see you joining us, and we start in 1 minute.
Less is more when you keep my data in check. Hey, I think you're the best for me. Hey, 'cause you help me see. Whoa, 'cause you're my index. Whoa, my data's in check. Whoa, 'cause you're my index. Index.
Hello everyone! Hello and welcome to DataStax Monday Learning. It's been a while since the last run, and we happy to be back online. That's Alex Voloshev, developer advocate lead at DataStax Developer Relations team, and today with me our special guests and one of the best expert in the streaming platform and messaging systems, Zach Dean. Hello Zach!
Hi everybody, how you doing today?
Yeah, it's amazing day, and well, maybe at my place weather is not so amazing. I hope you are more lucky. But we have attendees from all over the world, so I bet we can have people with the great weather, not so great weather, bad weather as mine, and maybe even worse. But that doesn't matter. What really matters, it's Monday and it's a DataStax learning time, and we are going to talk about incredible things today. So, Zeke, what's the main topic for us today?
Today we're going to cover the history of streaming, enterprise messaging design patterns, and then we'll jump straight into Apache Pulsar, the newest, latest, and greatest technology.
Yep, definitely. And if you never have been at one of our streams before, I have to say what that's a DataStax Monday Learning, the channel and the program. We cover most important technologies which ever developers has to be familiar with, at least a little bit, or better, become a professional. Our last big series was Docker Learning Path out of 5 episodes. And now this is the event streaming series of 3 episodes, and we are happy to greet you again. If you have been there already, you know who we are, and if you haven't, just a few things you need to know. That's only from engineers to engineers, open source only technologies, hands-on experience, live communication with the experts. Well, maybe you watch the recording right now, but at the moment we are filming it, it's the 7th of June. It's a live episode with live questions and therefore live answers. So, as said, that's event streaming series led by Zeke and Alex, and it's episode 1, Introduction to Event Streaming. What is it? How it happened to be? Why it happened to be? And especially why you should care of it and why you should know how to use that. And before we start, I have to ask a couple of questions to you so we will understand you better. So, just a little bit of questions to you, and we go live. First one, please go to menti.com and use the code 65532834. You can scan the QR code next to Zeke, or you can enter the code close to me. Oh, I'm hiding the code, so let me hide for a second. That's better. And your QR code is fine. So, scan the QR code or go to menti.com and enter the code 65532834 and jump in for questions. Questions are a very important part, but it's also a setup, because in the end of this workshop we will run a quiz, and if you attend this quiz, if you give the right answers, if you are fast enough, you have a chance to earn the prizes from DataStax. So jump in for Menti and don't close this tab. Be ready for the quiz in the end. Easiest way to go for Menti is just open it on your mobile phone and keep it open till the end, when we will have a game with the prizes. So, take a look. Looks like Python took the first place. Well, quite expected. And then the second place, There is a collision between Java with 29 places and JavaScript with 28 voices, which is nice, but Python still holds the first place. Next one is taken by C, so quite surprisingly, and C# and all the others are taking smaller part. So biggest part of our attendees today have Python, Java, JavaScript or C background, and that's quite interesting. And that's quite interesting also what there are some people with no programming language experience. Well, ladies and gentlemen, with no prior programming experience, this one may be a little bit a rough ride, but you will make it. We are here to answer your questions. Not just we, by the way, but also there are multiple people in the YouTube chat and Discord chat answering your questions. So, which queuing and messaging technologies are you familiar with? You can pick multiple options. Okay, Kafka, well, quite expected. ZeroMQ, IMQP, MQTT, well, so Kafka is a pure leader. Pulsar, oh, we have some people with Pulsar experience already, that's great.
Very good.
Yeah, but in general, that's quite expected. Kafka, known, RabbitMQ or ActiveMQ, Pulsar, a little bit of ZeroMQ. And well, GMS is also has some presence. Okay, good. Okay, if you have no prior experience with queuing or messaging, you have nothing to worry about, because that's exactly the workshop for you to get your first step into this world. And if you have some experience with the systems like Kafka or RabbitMQ or others, that definitely makes make it easier for you to get the content, but we still have something incredible for you. Because you see, game has changed a little bit with Apache Pulsar. We will discuss in the second part of the workshop. Cool. So, tell me another thing. How much experience do you have with Apache Pulsar? I've seen that there are some answers. But I bet, yeah, most of you never heard about that. So, know the concepts, that's good. Use it at once or two. Okay, that's quite expected, but we don't have experts in the stream, which definitely makes sense. Good. So, have you been to any of our workshops before? I've noticed some familiar names in the chat. And hello everyone. I see SM. I see some people here. Ivan Garcia, Tiago Candeias, Anil Kumar, Vijay Prakash. Yeah, that's great to have some familiar names. Oh, Saverio Guzzo. That's great to see you again. Cool. So, once or twice, I'm your fan. You are the best. Thank you. And some of you never have been here before. Don't worry, that's not a problem. But you need to know what we run a lot of workshops, a lot of great workshops moreover. So mostly probably you need to push the subscribe button next to Zig, because we have some more upcoming great workshops even this week. I will talk about that in the end of the workshop. And thank you. We are done. And that means we can go to a presentation. Don't close Menti, you will need it for the game. And we can start. So, Vladimir Druzhinin. Hello. Hi, Vladimir. Yes, we have an incredible team of attendees here today. So, what are we going to talk about today? Fundamentals of modern messaging platforms. Those are great tools, but that's interesting to take a look how it was before and why we should care about that and how it's developed over time. When we will work a bit with Apache Pulsar, and finally we will hands-on pushing the buttons and running Pulsar and sending messages using modern messaging platforms. You will do it. I will only show you how to start and you will do it on your own. And finally, we will have a quiz. We need to include the 4 the point number 4 in this list. So, and then fundamentals of messaging. How it started before. Originally, we had huge monoliths, huge platforms answering some queries, answering some questions, and all communication from client to the monolith and maybe from monolith to another service to fetch some data was done usually via things like remote procedure calls or whatever was it. It was mostly probably a normal HTTP, okay, doesn't matter, call, which was a great thing. I mean, definitely better than nothing. You are able to communicate with a remote system, but it also had some problems. This approach is great as long as it fits your use case. So I'm not going to tell you what things like RPC are gone forever. No, there's still plenty of space for every approach. But it has some troubles. And over time, with the development of the systems, those troubles started to trouble too many people. So, how it normally works? If your application needs to retrieve some data from an external service, or if your client wants to retrieve some data from you, doesn't matter, it's still going to be a request from some application I or client A to service B or server B. And then after some time, servers B responds. Hopefully responds, because it's a network, and network is a fragile story. And what's the problem of this approach? It is not exactly slow, because asynchronous call will work with exactly the same, will be executed within the same time, under the same conditions, of course. But as long as service B is not answered, service A waits for the answer, doing what? Doing nothing. And it has huge risk with networking, so your service must be available. Your services needs to have or service discovery or manual configuration, how service A will access service B. They need to know it in advance. It's a point-to-point communication. And that's important to understand. At the moment I make a phone call, I am the one who sends I have only one sender and I have only one receiver. So far it looks good, but we can have it better. And it's, well, maybe not exactly slow, but it's definitely blocking as you wait for server to respond. And if a receiver is not available, process is failed. Even though the processing by itself could have been delayed, that's important to understand. If receiver is not available, process is failed, even if there were no urgency in processing this query. And as said already, one and only one receiver. Blocking, not maybe so stable, maybe not so efficient. Let's take a look what changed and what other approaches were suggested. And there is a question from Avinash. Is this an alternate to REST APIs for communication between servers? Basically, it doesn't matter if it's a REST API or remote procedure call. They utilize the same blocking synchronous approach. So in this example, you can just take remote procedure call and replace it with REST API, and nothing will change. Literally nothing. Am I missing anything, Zik? I believe they are completely interchangeable.
Yeah, they're pretty interchangeable. I mean, remote procedure call, it was basically a way that you would code like on XML RPC. So you'd have a Java client talking to a Java server, you'd make a request to the server, and the server would respond. So it's kind of like HTTP, but it's even more like lower level. It's designed for like application messaging. But yes, it's over something like HTTP.
Yes. So, you see, does it work? It works. Is it enough? Well, maybe we may need something better for some different use cases. And then message systems came to offer something different. What was the principal idea? What's the general idea? you need to remember. It was, quite surprisingly, to decouple senders from receivers. That's the primary point you need to understand. So now we have a mediator or messaging service. There are multiple options how you can call it, but idea is always the same for them. It's to decouple message senders from receivers by using a messaging service, something that handles your messages in a special way, treats them specially. Now, application A communicates not directly with a service B, but it communicates with a messaging service. And messaging service dispatches this request to service B, and service B gives the answer, and answer may be received by application A if it is interested in the answer, because there are some cases you may just want to give an order to process some data, but you don't expect the result. It also happens. So it's a persistent buffer to handle requests and payload. That's what important. It's asynchronous. So no need to wait. As soon as your message is received by a messaging service, it's considered done. And application A can start to process next request or do some external work. So this time in between from original request to getting the reaction, application A can be busy processing other requests or doing some useful work. That's very important to understand. So now another point. With message systems, one message can have multiple receivers. And that's very important from the ability to extend your system. With the monolith system, we use it to add some code. When we just make some processings, you need to extend it, you need to add some things, you need to add some additional operations on, I don't know, maybe if user ordering something in your internet store, you now need to add some additional processing to it. You go and change some code directly in your monolith. At some point, it's great, it's easy, but at some point it's getting too big, it's getting unmaintainable, and you want to solve it. That's why we started to spread applications into a distributed system, often decentralized system, systems like microservices, for example. And at this point, very often, idea to add a simple new processor to extend the behavior of your system was just to make a new microservice receiving the same message. Now, not only service B will receive this message, but also service C. And the question is, should you change anything in application A? No, not necessarily. Now it will be processed by your messaging service, and everyone who is interested in this notification, in this event, we can say, will get the update and can do something, can react something. So it's about the decoupling and loosely coupled architectures. Then, I already told that it's a perfect fit for distributed systems and microservices. And one more benefit, which sometimes very important, message will be consumed by the next available service instance. Let's imagine what we need to process a message sent by application A. It goes to messaging service, and there is no running instance of a service B at the moment. What would happen in the old school approach? As said, we wait till time to leave is done, and when we get an exception and everything is broken. For some of the use cases, yes, that's a valid situation. For some of the use cases, you need to know immediately if this request cannot be processed right now. But it's not always like that. Sometimes you are completely fine to get the response hours later. For example, making domain name management system very many years ago, we had to wait for the propagation of the newly registered domain name over the planet. And in some cases it took, well, it was quite some time ago, it took up to 12 hours, up to 20 hours. In this case, I don't need the confirmation right now. It makes no sense to put my HTTP call or RPC call any API call to wait for 12 to 20 hours. It makes no sense to make it in a blocking way. No, I want it to be asynchronous. And then it's completely fine to me if service B, just the next available instance of a service B will get back in few seconds, and then we will process my message and dispatch the results of this processing to the messaging service again. That what makes sense, and it works in a very reliable way. So for many of the use cases, this approach fits much better. Not for all, but for many of them. And before I proceed to next question, to next slide, I want to say, where do we get a copy of the presentation? Use it here. We have, that's a materials link attached to the video. And hi, Ion, very glad to see you. So we have a lot of friends here today. Good. So, then, how that works? There are two main ideas, notifications and queues, but they work in more or less the same way. So before we proceed to the type of those messaging systems and approaches within those different systems, we have to cover on how exactly they are working. And there is an incredible question from Deepak I want to answer right now before proceeding. What happens if a receiver is unable to process the incoming flow of events? We will cover it a couple of slides later, but if you ask me in person, why do I like messaging systems? My first answer, my first idea would be they help you to build really scalable systems. And if you have a flow of the messages so huge, what service B cannot process them, answer is, we see how many messages we have here addressed to service B. You have it into your monitoring and you simply spawn next instance of service B. You spawn next instance of service B, and in the end you spawn as much of them as you need to process all of them. Today, with the modern approaches with the clouds and with the ability to run a new instance of a service within some seconds sometimes, or in the worst case scenario, some minutes, that's an incredible way. So if service B cannot process such a flow of messages, scale it out. Simple as that. Messaging system helps you to scale. So we will get back to that. How it works again. Now take a look. We have three players in this game. Three instances we have to consider. We have provider of a message, or provider of a notification, provider of a queue message. And we have service consumer. Consumer is someone who is interested in the message we are going to dispatch. In this example, provider is a service A, and consumer is a service B. But that's interesting, way can change. So usually the same service B can be in this time, both provider and consumer. So first, service provider or event provider registers in event manager and says, hey, I'm here, I'm going to dispatch event A, something happened, user registered, something order executed, or whatever you want to do, and that's it. Notice what between the registration of an event type and the real event, there's a huge difference. Because here, down on the time, we see event A occurred. It's not happened here, it's just a registration. Okay, I'm going to dispatch information if something happens. And in the next step, consumer can go to event manager and say, hey, there are multiple consumers, and they say, we are interested in event A. It can be single consumer or multiple consumers, doesn't matter. Then service provider dispatches this information. Okay, event A occurred, something happened, order, something else, domain registered, or whatever your system takes care of. And as event manager knows, whatever consumers interested in this type of event, it will dispatch these event details to the service consumers, so they will know, okay, finally it happened, we have some job to do, amazing. So, and that's quite cool. So at your consumers and this registration, this subscription, it's a flexible thing. Today, consumer 1 is interested in this event. It will go and subscribe. Tomorrow, it's not interested anymore. It will go unsubscribe and it will not get subscriptions again. And of course, different consumers, different applications can make subscriptions to different topics, to different questions and to different event types. So of course, it's highly configurable, and provider and consumer are detached, decoupled, and they don't belong to each other. That's a flexible and loosely coupled system. So it's all started quite a long time ago, and that's basically begins with one of the most well-known systems. First one, IBM messaging MQ series system, created like quite a long time ago, and then there being development in the end of the 20th century. Java messaging system was introduced. This one became more popular, and not because it maybe was better, but from the point of view like the amount of companies, amount of projects what needed messaging systems started to grow tremendously. That's important to understand. What for dozens of years think what really limited us was a bad internet connection. It doesn't matter how fast your database returns data if your client has a 56K modem, USR robotics, and is going to download data within the next half an hour. You don't need fast database. But as internet connection gets better and better, people already don't want to wait. People want to get answer now. And systems are getting bigger and bigger, and you need to be able to scale it out. So messaging system starts to grow then. When we have things launched for like ActiveMQ, and this one already was quite well known. I've seen some ActiveMQ users in our Menti quiz. And system I was working the most was launched in 2007. It was RabbitMQ, and it's still quite good, but the real hit was in year 2009 with Kafka. And I believe Zeke will have a lot of things to talk about Kafka today as well. Okay, so we have a lot of things going on, and the one thing we have to remember, amount of customers, amount of users, amount of people in the internet doubles very quickly every couple of years, and we have more and more load, and we have more and more data. So as synchronous blocking calls were not a good fit for a lot of use cases, that's what brought messaging systems to us. What are the main features for messaging systems? Asynchronous communication, message retention, acknowledgement, and message consumption. Let's take a look at that. First one, we have to remember there are two main approaches in the world of the message dispatching: queues and pops up with notifications. I prefer to identify it as notifications and queue messages. Only two, so it's quite easy to get. If you have experience with Amazon Web Services, there is a simple notification service and simple query service, SNS and SQS. Basically, that represents the idea: queues or queue messages or notifications. What is that, and why do we need two? Because they feed different purposes. That's why we need two. Let's take a look first at the queues. Simple idea of a queue. We may have producer or two producers, multiple producers, publishing some messages or queue messages, and we need every message to be processed once. What's the story? For example, you upload images to cloud, or your client's uploading images to your system, and you want to make a thumbnail. Like with old school traditional approach, with no queues, with no messaging platforms, while we are uploading this image, you have to, on the fly, grab this image, generate a thumbnail, and only then their blocking synchronous request will be returned like, okay, we got it, that's good. But you know what? That's so old school and not necessarily, and there is no need to generate thumbnail right now. So I want to do it later. It's completely fine if it will be done not immediately, but in a couple of minutes. If my system under heavy pressure, even in an hour, there is no big difference, there is no big problem. No one will die if this message will be processed 1 hour later, okay? So no worries. But I don't want this message, I don't want this order to create a thumbnail out of a big image to be processed twice, just because it's redundant consumption of resources. And I want my system to stay efficient. So I want it to be processed once. Another example would be buying order. Like I want to buy something. I don't want to buy two things for double the price. I want to buy exactly the thing I'm buying now, one thing, one unit for the price specified. I want my order to be executed only once, and that's a second good example. So, queuing, that means what any producer may publish a queue message which will be processed only once and only by one consumer. Then you can ask, okay, with multiple producers, it's more or less understandable. So the same information may come from different servers, different data centers maybe, that's clear. But why do we have multiple consumers here? Consumer 1, consumer 2. That's important to understand. Those are the same service B, but different instances of it. And every message in this queue is something what represents my order or my image to generate thumbnail based on, or something like that. So every entity what has to be processed only once. And that's why first and third messages, first message will be processed by consumer 1. Let's imagine it takes some time. But we have more messages in a queue, and then next available consumer grabs this one and start to process it. Then consumer 1 is free again, and it says, okay, what's the next in the queue? Anything? Yeah, there is one more message. So it will take the third message. If queue is empty, those consumers will stay quiet. They have nothing to do. They are idling. But as soon as you get something in the queue, consumers will pull it and produce it. One message will be processed only once. Sweet. And what's the best benefit of that? First, if anything bad happened on your backend, if no instances of service B are available, both are dead or all of them are dead, no one is able to process the message, no problem. Because messages will stay in the queue, giving you time to restart consumers. Or maybe you are deploying a new version of Service B. No worries, there is no downtime. You just wait for a couple of seconds when new instances will get back and replay thing from the backlog of messages, so from the queue, and process them. So you are good. And if you see what amount of messages in a queue are huge, if you see what we have 500,000 messages in a queue waiting to be processed. What does that mean? Mostly probably you have to launch more consumers. And as this architecture suggests you to have stateless, simple stateless services, they are very easy to scale. And that's a second thing I really like regarding this decoupled architecture. So exactly one processing of messages. That's clear. Only one consumer will get a queue message. Backlog of messages. Yes, that's clear. I will get a message when I need it, as soon as I complete the processing of the previous one. Then distributed processing. Those consumers may run on the same host, on the same server, but does it really make sense? No, I can run second consumer on the second server. I may run third consumer on the third server. And as a result, I will have as much of them as I need, maybe over multiple continents. And they always running in a distributed way. So even if the whole data center of a consumer 2 is wiped out by a hurricane, I still will have consumer 1 in another data center, and distributed processing is a cool thing. So message failover, if consumer started to process a message, but when failed, got an exception, failed as long as this message is not acknowledged, it will get back to the queue, and it will be processed by next available consumer. So message failover is a very cool technology. You have to be careful at this moment, because you need to think when exactly you have to acknowledge message. Because if you didn't yet process it and acknowledge that, it will not get back to the queue if something happens with consumer. Then it's for you to take care of persistent processing, okay? And then easy to scale, well, I said. Usually this architecture suggests you to have them distributed way, and you can add them as they are stateless as much as you need. So far so good. Then what's the publish subscribe? It's exactly different thing. When we speak about queues, we think of the multiple huge amounts of the consumers processing messages. That works. And then the question is, what do we think about publish subscribe messaging? It's not about exactly scaling, like ability to handle 100 messages, 1000 messages, 100,000 messages, billion messages, but message consumption in a PubSub mechanism is about the extension of the behavior of your system. For example, I want to buy something in an online shop. And first thing, in a very simple example, behavior was for system to process the order. So grab money from my account and book some goods on the storage to send to me. But when over time, system develops like Amazon does, and now you need to do more and more things in exactly the same situation. So publish subscribe messaging is different. With queue, we have to be sure we use queue when we need to know what one queue message will be processed only once. With PubSub messaging, it's absolutely different. With PubSub, we want a notification or event to be processed by all the consumers what are interested in it. For example, we are doing an order in an online shop. First consumer received an event, oh, we have an order, new order. First consumer will take care of the logistics, create a shipping order to the address. Second consumer will process the banking process, like pull money from my account. And third consumer, which is not present on this picture, but it may exist, will obviously send an email to me. That's a special mail service what sends an email. Hey, thank you so much for your order. Here is a special thing you may like to buy next time. And then if you want to add some processing, if you want to extend behavior of your system, you don't have to change your producer. You don't have to change topics or subscriptions or consumers. You just add one more consumer. Simple as that. So, idea is very simple. Producers send notifications to topic. Consumers subscribe to this topic. You may have multiple consumers. Easy to extend. Every notification what has some subscriptions will be processed by all the services those subscribed for this kind of a notification. So Q mostly for scalability, PubSub mostly for extending the system behavior. So that's the story. Message-oriented middleware started quite a long time ago. Basically, you know what? That's hard to say, but it's almost 30 years ago already. By the way, that's interesting to notice what infamous AWS, Amazon Web Services, the first public service they published, again many years ago, was also belonged to this PubSub and Q story with SNS and SQS. But get back, message-oriented middleware came from IBM WebSphere MQ in 1993, such a while. It was a breakthrough, I would say, but, well, 1993, what would you expect? It also has some disadvantages. First one was, it was a single machine design, so it was a server, quite powerful one, but one and only one. If you want to upgrade it, you have to go to vertical scaling. You know, DataStax, company behind Apache Cassandra, we don't like vertical scaling. It works till some limit and then you are into troubles. And also, single server introduces single point of failure. So we need to maybe have something better. Then it started to extend. Single host is not enough. So now with the help of a network load balancer, we may have multiple message queue servers, 1, 2, 3, as much as we need, working with different topics. Is it better? Well, that's definitely better than single machine design. It's quite easy to be better than single host design. But that's not exactly solves the problem, because now, yes, we have spread it the workload, but in which way? First server is responsible for first topic or set of topics. Second server responsible for different set of topics, and so on and so forth. Basically, it means what if this server goes down, this topic will be not available and your system is blocked. Do you like it? I don't. Going on this way to develop a system, we go to enterprise message bus with a message routing. It's a more advanced thing. Basically, it belongs to so-called service-oriented architecture. Enterprise message bus is an essential part of the service-oriented architecture. What does that mean? So, it helps you to exclude this point-to-point communication from service A to service B. Service A just publishes message to the bus, which is a quite big advance in comparison with old systems. Then message will be routed by service bus, by message bus to service B and service C, so those who want to receive the notifications. And meanwhile, data enrichment and transformations are on its way. So if, for example, service B and service C needs the same data, but format in a little bit different way, well, then message bus may take care of it. So that's good, and that helps a lot already working with, let's say, heterogeneous systems of different kind of applications. Being split into 3 different layers, serving, compute, and storage, Enterprise Message Bus worked quite well to deliver some features. First, dynamic routing. So consumers may appear and disappear using different IP addresses, different data centers, different networks and continents. It's still possible to reach them. It may do transformation for data. For example, some of your consumers may need XML format data, while some of them may need JSON. We can do transformation on that, and every service will receive data so it will understand. Message enrichment. Sometimes to deliver data to a consumer, you need to get data from multiple sources, because we have service or application A giving only the part of the data We know because of decoupling, and we may need also data from application Z, and then we have to bring them together, so we enrich data from other sources before we deliver it to consumer. And of course, message processing. Regarding the message processing, that's what we will discuss later today, so I will not stop on that. And then finally, enterprise message bus was a very good thing to establish third-party integration with other services. Is it some third-party application of some of your partners, for example? Is it customer service or some different departments of your own company? If it's an email server which sends or vice versa receives data, and is it a database to store some information? So it was a huge step forward. Then basically Kafka came, and we want to speak about already better distributed messaging systems. And you know what, Zeke? I'm talking and talking and talking. Now it's your turn. I will only get my water and listen to you and answer questions meanwhile.
So my only question is, are you going to continue sharing the screen and I'll ask
No,
you
no,
to
no.
advance?
You have to share yours, and
Okay.
I will switch back to yours.
Got it. Okay. So I have a question for the audience. Can everyone see my screen?
Just a second, I'm switching. Yes, now you must be good.
Fantastic. So basically, Kafka was invented around 2009 as kind of it's called a distributed commit log. And what this means is you're able to store all your messages as an append file system. And we'll talk about a little bit about that later. But essentially it means is that you're inserting messages into a server, and this message is then copied over 3 times. So basically the idea behind Kafka was to offer complete and total horizontal scalability. So unlike all these MQ style systems, there's what's called a primary and secondary messaging systems. So for a particular server, if you go back to like the MQ days, you'd have a primary server and then you'd have secondary servers. In Kafka, each node in the cluster will be serving data for the various applications. So basically the idea behind it is node 0 would have ownership of partition 1, partition 2, node 2 would have ownership of partition 3 and 4, and so forth. So basically, a distributed system can be described as a way of distributing data. And the idea behind this was you would horizontally scale it. And the design around Kafka was to serve the data as well as store it on the same node for high performance purposes. And it came a lot from using the Hadoop-based architecture as well. So if you're from a Hadoop architecture background, you'll have some good ideas therein. So what is Kafka great for? Now, I've been a Kafka consultant for about 6 years, so I have a pretty good understanding of this. So basically, Kafka is really good for just streaming data. So because it's what's called a distributed commit log, you're able to add messages the end of a file. So because Kafka doesn't have any kind of searching capabilities, no indexing, it's not doing any kind of random disk access, it's not doing any search queries, you're literally adding a file to the end of a file system. So if you've taken Computer Science 101, right, adding an item to the end of an array is very easy compared to sorting an array, or worse, inserting data into the middle. So it's just inserting data. That's all that Kafka is, and that's why everyone loves it, and that's why it's so fast, because Computer Science 101, right? If you're adding an item to an array, all of one operation. I hope everyone in the audience has taken some kind of basic algorithms. So that's kind of why it's so fast. It's an append-only file system. And that makes it great for streaming because the data is going in real time. Now, unlike RabbitMQ or all these other MQ systems, ActiveMQ, IBMMQ, they're not really designed for having, let's say, 1,000 machines or 100 machines, maybe even 10 machines for one single cluster. Kafka is designed from the beginning to handle as many machines as you want, given you have enough partitions in the cluster. And it's well known for high performance as well. The key architectural difference between a distributed messaging system and a distributed clustered single node system is the way the storage layer is designed. So in these previous single node systems, the data layer for any given topic is stored on the same machine, and this limited the size of the topic to the capacity of the local disk of that machine. So within a distributed system, the data is distributed across several machines within the cluster, and the distribution of data across multiple machines allows us to retain messages for an individual topic that exceeds the storage capacity of an individual machine. So the key architectural abstraction that makes this distribution possible is called the write-ahead log, which treats the contents of a message queue as a single append-only disk structure which can be stored. So as you can see it in the diagram over here, right, we're basically writing data to these various different partitions, and each of these partitions are an append-only log. So this provides distributed messaging, which is far more scalable storage capacity than any of the previous generation of messaging systems. So remember, RabbitMQ, IBMMQ, ActiveMQ, SwiftMQ, any of these MQ systems are designed to delete the messages immediately after sending them. So you can't replay messages. You can't do, a replaying of a whole streaming data flow. That's kind of the power of Kafka. End-to-end storing data, streaming through it through a distributed processing engine, and then because it's a distributed processing engine, you're able to essentially do all this fantastic real-time analytics. So another benefit of distributed messaging architecture is the ability of more than one broker to serve the messages for any given topic. This increases the message production, the message consumption throughput by spreading the load across multiple machines. So, for example, messages published to the topic would be handled by 3 separate servers, each with its own write path to disk. This would result in a higher write rate since the load spread is through across multiple disks, rather than a single disk as a previous generation of messaging systems. So, these are the two distinct approaches when it comes to how the data is distributed across the nodes in the cluster, partition-based. And that's kind of the power of Kafka. Now, what are the problems I ran into with Kafka, given my 6 years of experience with it? Well, basically, Kafka is all about partitions, right? And if you design your topic correctly from the beginning, you'll never have to add another partition again, which is perfect. However, when you add a partition to a topic in Kafka, that's a massive headache. So what that does is it basically requires you to move all of your existing data in that Kafka topic to these new partitions. So all your messages are rekeyed, they're resorted, they're redistributed, your data goes to different partitions. And if you have any active consumers running, what's going to happen is those consumers start reading different keyed messages. So the way your data is distributed changes fundamentally, and you have to plan downtime for a topic. Generally speaking, when you're adding a partition, you're going to be doing this in such a way that it's just very hard to scale it there. And if you want to add a server to Kafka as well, you have to do what's called a partition rebalancing event. Partition rebalancing events are very expensive. What this means is, again, you're copying data over, there's going to be some outages. The way you scale it is through replication factor as well. Next step to consider is application development. So application development of Kafka is a little tricky because, you can't assign a specific consumer to read a specific keyed message. So if you start adding messages to your partition, you'll run into any issues. Hey, Alex, I hear your keyboard typing. Do you mind muting a little bit, or?
Yes, sure.
Thank you.
That's only you who hear that, but don't worry. Yeah, I will lower it for you.
Okay. Okay, thank you.
Mm-hmm.
So basically, if you're using something like any of these MQ style systems, it's very easy for, a consumer to subscribe to a topic, and then the broker itself to do data enrichment, right? So in MQ-style systems, you can do jQueries, you can do XLLT on the broker itself, which will filter the messages and route those to specific messages. And you can also do things like priority queuing. So these are features Kafka simply doesn't have. And that's why, MQ exists. They still do. Why Kafka never replaced it. So there's other issues as well. There's a lot of lost messages, CPU spiking due to stream processing issues in RocksDB, and out-of-order messaging, which is a very common use case. So we're 1 hour into our workshop today, and now we're going to cover the basics of what is Apache Pulsar, which is why you're here today. So I'll cover the introduction, the architecture, deployment and development models, different application components to the ecosystem, some of the messaging processing components, multi-tenancy and geo-replication, and finally, hands-on keyboard exercises. Now today is a quick introduction. Next week we'll be doing a lot of hands-on, coding and development, and then the week after we'll do some integration examples. So what is Apache Pulsar? Well, basically, it's a distributed publish and subscribe messaging system designed for high throughput and low latency. It completely separates the compute layer of messaging from the storage layer. So there's a completely separate messaging service called the brokers, and there's a completely separate service layer called Apache Bookkeeper. And we'll cover that on the next slide. So it's horizontally scalable for every aspect of messaging. So if you need to increase, your message volume, you add more brokers. If you need to increase your computation capability, that's when you also add more brokers or bookies. And it also features streaming and queuing. So it was originally developed at Yahoo. So it was added to the Apache Foundation in 2016, and now it's a top star project in 2018. About 7,200 GitHub stars and 300 committers. So what is it? Well, basically, it's a distributed tiered architecture, right? Separation of storage and compute. Now, of course, there's Zookeeper in this equation, and Zookeeper is fantastic for metadata. You use Zookeeper for holding metadata information, like which machine is the primary keeper of which partition, which broker is serving, which customer and which custom client connection details, which function is running which application. So that's basically the role of Zookeeper. It just stores like which machine owns which aspect of the system. So it's a very small piece of the Apache Pulsar equation as well. And then you also have these stateless brokers, which are responsible for connecting to producers, consumers, and they also can run SQL functions and what are called functions, which we'll cover later. And the storage is handled by Bookkeeper, which is also a distributed append-only log system, very much like Kafka. And the data is broken into segments written on multiple bookies. By the way, I can't see any questions at all, so if anyone has any question, maybe Alex jump in and ask on the audience's behalf.
We are answering all the questions in the YouTube chat, so we took care of that. And looks like all the hours are thoroughly listening to you.
Okay. So why Apache Pulsar? Well, we have several blog articles out there. There's an excellent one called 4 Reasons Why Apache Pulsar is Essential to the Modern Data Stack. So you can go check that out. Just Google that article. There's also a link to it here in the slides, which you should get at some time. So basically, Apache Pulsar has geo-replication built out of the box. So you can have a cluster in Europe, you can have a cluster in America, you can have a cluster in China, and they could all talk to each other. Now, if anyone here is a data engineer, they're concerned about GDPR and, data isolation, don't worry. Pulsar features message encryption, encryption connections, and encryption at rest. And you can also isolate your topics, your partitions, your machines. So don't worry about, geo-replication with no concerns. It's geo-replication with a lock-in key. Second is scaling. So because Pulsar completely separates the compute layer and the storage layer, you can throttle each one as needed to lower your costs or increase performance. Next is multi-tenancy. So Pulsar is designed as a unified event messaging platform. What this means is that you can run multiple business units, multiple customers, multiple needs on a single cluster. So generally speaking, when you come from the Kafka world, you're going to deploy many small clusters just because of the nature of the beast, right? You need to isolate your data. Different teams follow different standards. Different customers have different needs, and you want to make sure that you can't exactly query those different data streams. You want to keep everything fully isolated. So because of this lock and key approach to topics in Pulsar, and because of tenants and namespaces, which we'll cover a little later, you're able to really lock down, the way things work from an architectural perspective. The next thing is it has traditional queuing, so you're able to run MQ-style messaging in Pulsar. We actually developed a JMS driver as well, so you can run these old-school Java messaging service applications on a Pulsar cluster. We're 98.5% compatible with all of their requirements, so it's a lot better than other technologies out there. Cloud native as well, so you can run Kubernetes right out of the box. It's designed from the ground up. It has something called a proxy layer, which is used for service discovery. And there's actually some documentation as well on how to set up multi-region clusters. It's not very hard. And performance. Again, separation of compute and storage means that you can have a very consistent high performance. And we've generally seen very consistent low latency. Around 7 milliseconds seems to be a constant number I've been seeing, at least in my own testing. So what are the deployment options for Pulsar? Well, we do have some new serverless architecture coming out soon. I'll stay mum about it, but maybe we'll do it later in the workshop series. You can run it on-prem using Ansible scripts or Kubernetes, so both of those are available. There's Docker images. They're all Java-based. We have Helm charts as well, so you can get your Pulsar running as soon as humanly possible, which is pretty exciting. Then finally, we have Pulsar as a service. So DataStax acquired a company called Kesk, and Kesk was providing a managed service for Pulsar. And now we're launching a Aster streaming, so you can run all this fantastic Pulsar exercises in the cloud without having to learn anything about administering a Pulsar cluster as well. So that's coming soon. What about developing with Pulsar? So in the exercises on part 2 of the series, they'll be mainly in Java. However, Python is my favorite language in the world, so I'll probably provide some Python code next week as well for part 2 of this learning exercises. You can also do Node.js, and yes, you can run a WebSocket directly on Pulsar, which is pretty cool, right? So if you're making like a web-based video game, if you're doing like some kind of stock tracker, you could hook it up via a WebSocket to a Pulsar cluster through the proxy. There's a RESTful API for administration, so you can also, handle all the API layer details as well. So you can call and make different things. If you need to develop on .NET, there are client libraries out there along with Rust and Haskell. So what are the different components to Pulsar, and what do they involve? And so basically, you have Zookeeper, which is responsible for the metadata and configuration details and coordination. So Zookeeper is literally just storing a table of information in a distributed clustered manner. So that's all it has. Generally speaking, when you deploy Pulsar, there's 2 Zookeeper clusters. There's what's called a global Zookeeper. So if you're running like a single worldwide cluster, you need a Zookeeper to manage all the local clusters. So remember, in our earlier example, we had a cluster in America, a cluster in Europe, a cluster in China. Each of those Pulsar clusters will require its own Zookeeper for, metadata information about ledgers, partitions, broker IDs, client information. Next, you have the global Zookeeper, which basically keeps track of how these different clusters in different locations talk to each other. So that's pretty much what they're involved for. They're doing what's called tenants and namespaces, which will be very important for these things as well. By the way, if anyone has any questions, feel free to, pause and ask me, but otherwise I'll keep going. So a broker is a stateless service, and a broker is responsible for interfacing with the producers and consumers application. Now, thankfully, Pulsar has service discovery, so unlike something like Kafka where you need a giant connection string, with Pulsar, you just connect to a single DNS endpoint, and in that DNS endpoint, you're basically running your entire cluster behind a load balancer. So Pulsar is the broker is basically the brain of Pulsar. It's where you run all your RESTful administrative APIs. It's where all the producers and consumers request their data. And the brokers are also responsible for running Pulsar functions. We'll cover Pulsar functions later. A broker is also responsible for topic ownership as well. But pretty much as you can see in this diagram, right? The producer goes to a dispatcher. The dispatcher goes to request different data fields from the managed ledger, which has its own bookkeeper client, which then talks to bookkeeper, which then gives the data back to the broker, then that goes to the consumer. So that's what the broker is. So a broker is basically responsible for the dynamic assignment of data. Topic ownership can change on the fly. A broker can crash, and a broker can be overloaded. And the fortunate thing about the broker architecture is you can very easily add more brokers if you need to process more data, more customers very easily. There's also a ownership assignment granularity. So we have this thing called namespaces, and we'll cover that much later. But basically, you have these namespaces, and you can do Cassandra-style hashing. Broker also offers what are called unloaded topics and bundles, which triggers a topic reassignment based on the current workload. It's manual and automatic. You also have this bundle split feature, which can automatically trigger topics. And finally, you have automatic load shedding, which forces topics to go from overloaded brokers to available brokers. So it's very good for like keeping a consistent low latency, high performance, because the broker, again, is responsible for the messaging, sending, and receiving. So it's responsible for just brokering. I'll pause if anyone has any questions. I just went through 20 slides in 20 minutes. So I speak fast. Any questions?
No, you are good. Well, there is a question what I didn't. Okay, there are two good questions actually. So let's answer them live. One question from Murat. From management perspective, Kafka versus Pulsar, which one is more difficult?
So the tricky thing with Kafka is whenever you need to add scalability to it, it's very difficult, right? Because you have to add a partition, rebalance those partitions, and then manage each and every single one of your brokers. So going back to the original diagram, I'm going to go back very far. It's this one, right? You have a serving layer and a storage layer. And the problem with Kafka is you can't separate the serving layer and the storage layer. So therefore, you have a lot of pain points where you need to serve more data, but you don't need to serve more. So therefore, you have to add more broker nodes. And those broker nodes, adding them is very expensive, right? You have to basically add a partition, do a rebalancing event, and then when you do a rebalancing event, you have to wait for it. It causes all sorts of CPU hiccups, disk hiccups. If you need more storage, you have to add more disks. So because things aren't exactly logically separated, it just adds like unnecessary stress to the situation. And when you have this stress, you're also interfacing with other things. Now, there are plenty of companies out there that provide managed services to make it operate better, but the technology itself should ideally just work. And Apache Kafka has a lot of pain points around the operations side of the equation. Did I answer your question there?
Yeah, I think so. For me, it sounds really reasonable. Then next one. If I am already using Kafka, what would be the main reasons for me to move towards Pulsar? Question from Tarak Navsingh.
All right, Taraf, that's a very good question. And I hosted 2 webinars recently that covered, what is Pulsar from a Kafka perspective and why would you consider migrating from a Kafka perspective as well? They're both available on our website. But pretty much the reason you would look at something like Pulsar is you would use Pulsar as like a layer on top of Kafka or as a layer on top of RabbitMQ. So basically, Pulsar is your single unified event streaming messaging platform, and you can run a single worldwide cluster through Pulsar. So you can take, all this Kafka data and then federate it to very specific namespaces, bundles, topics, and authentication. So the benefit of running Kafka on Pulsar is you basically get the ability to organize your data in a much more structured and fundamental way. The second reason why you would consider, using Pulsar coming from a Kafka background is if you're just doing producers and consumers, Pulsar is very, very easy. You can subscribe to a topic and you can also do key-based messaging. So you can subscribe to a key and then you can read only from that key and then process that keyed message on a topic. We'll cover those kind of application designs next week as well.
Yep, great. Oh, sorry. Have you answered it?
I did.
Oh, okay. I was afraid I'm interrupting you. So, a very interesting question from Tiago Candeias. Can you currently use Pulsar in cloud providers, serverless, like AWS or Azure?
So we do have a service coming out soon called Astro Streaming, and we're launching it imminently. And when it launches, we'll cover it in one of our soon workshop series. But we also have Kesk, which you can use right now to get started. And you'll be doing some hands-on exercises as well later today in the cloud with Pulsar. So don't worry, hold tight, wait like 10 minutes, maybe 20, and we'll do some hands-on stuff. But
Yep.
yes, you can run it on a cloud provider. You don't need to roll a server out of your closet and set it up. You can run it on the cloud. The wonderful thing about Pulsar is it's very, very, very easy to just set up and run in the cloud. I'm thinking we'll do that in the third workshop, deploy Pulsar in Azure. I'll just walk you through it. It'll be pretty fun.
Yep. Cool. Well, there is a difference between run Pulsar in cloud and run serverless in cloud. As someone responsible for maintenance, I can say there is a huge difference. Yeah, but there is a really good moment to ask that because, Tiago, if you have heard of Astra or AstroDB, so Apache Cassandra as a service, managed Cassandra. Now, I'm not sure if it's secret yet or are we announced that already. Astro streaming with Apache Pulsar on the same conditions, so serverless, going live very soon at with DataStax Astro streaming. And that's quite cool. And maybe last question or a couple of last questions. Can you give some reference example from real life application, probably in a comparative way, which component can help to do what in this architecture? Question from Tanay. So can you give some reference example from real life application?
Yeah, I'd have to switch the slides entirely though. Basically, give me a second. Give me a second. Okay. All right, so I'm going to read a different slide. Yeah, I can do a different slide. So basically, when I talk about Pulsar, I like to talk about these use cases. And, basically Yahoo uses it for their mail services and their finance services as well. So they're running a full 10 by 10 cluster. So that's 10 clusters worldwide, all talking to each other. So they put all their financial and email services in their Pulsar clusters, and it's replicated worldwide, and they're able to stream it in, they stream it out, and it powers everything. The other one is Splunk. Splunk acquired a company called Streamlio, and Streamlio is a very good company. And Splunk, basically, they had a lot of challenges using Kafka for their own, log analytics business, and they discovered that, Pulsar was a lot easier to manage and develop on when it came down to these kind of things. And finally, we have a company called Xiaofin, which is a Chinese, company that basically is the single largest job board website in all of China. They have about 70 million unique page views a day and a lot of page views. And basically what they did is they replaced both RabbitMQ and Kafka with Pulsar to simplify their overall architecture. The other example is Verizon Media. So Verizon Media runs all of their, mission critical recommendation engines on top of Pulsar. So that's one very good example. Now let me get back to the continuing presentation.
Yep. We have a couple of more questions, but we can get back to them later because, well, show must go on and we still have some things to do today.
Yeah. So we need to cover Apache Bookkeeper very quickly. So basically, Apache Bookkeeper is basically your distributed append-only log, and it works exactly like Kafka, right? Where basically when you're a client, you connect to a broker, and the broker then interfaces with the bookkeeper. And the bookkeeper is then responsible for storing and delivering the topic information to the broker. And the broker has like topic data. So we'll have like a ledger. Maybe you'll have 3 ledgers in this example, and each ledger has a series of fragmented entries. And each of these fragments are what store the actual messages. And once you completely fill a ledger, it's closed and put away. So basically, it's a logical abstraction. A ledger is created when a topic is created or a rollover occurs. So basically, you create a new ledger when either a time-based limit is reached, there's an ownership change, or something. It's append only. So that means is you're always writing to the end of a log, not before, and there are entries and fragments. So basically, the bookkeeper basically hosts a fragment. So what is a fragment? Well, you can look at it like a partition in Kafka. That's the easiest way of thinking about it. And basically in this example, there's a cluster of 5 bookkeeper nodes, which means an ensemble of 5. So that means this fragment is going to be, can communicate with up to 5 brokers. And this is important for performance reasons. So an ensemble basically tells Pulsar, how many machines am I going to read and write from in real time? Next is the entries as well. So we will have like these entries, which are written to the fragments. Now, a quorum write of 3 means your data is replicated 3 times on 3 different machines, and you'll get an acknowledgement as well of 3. So this is coming from a Kafka world where you send your message once, it's replicated 3 times. So you're able to survive disasters, you're able to replicate the data. And this is also very much like Cassandra, right? When you replicate your data to, you can do local quorum, you can do quorum all, but basically the rule is very simple. You have the write quorum, which tells you how many places to write it, and then you have the acknowledgement quorum, which tells you, how many machines should acknowledge a message. This is very good if you're coming from a Kafka world where, you write a message once, it's replicated 3 times, and then you get the acknowledgement back after it's been replicated 3 times. So from a reliability perspective, this makes things incredibly good. Towards the end of this presentation, you'll learn that you can actually replicate messages all over the world. You don't need to set up some third-party tool. It's baked right into Apache Pulsar itself. And it's a write-ahead log. So Bookkeeper is designed for much easier process of recovery. So the process of replicating fragments to ensure a replication factor is maintained for each ledger. There's a manual recovery or an automatic recovery process. And there's dedicated recovery hosts or even sharing in the same hosts available. So putting everything together, you have your producers and consumers that interface with the Pulsar brokers, and those brokers then basically have their own metadata, which is stored in Zookeeper. But those brokers then request the data or send the data to the Bookkeeper cluster, and the Bookkeeper cluster is responsible for serving and storing those layers into their own cluster, which handles the replication factor. So you immediately see the benefits, right? In a world of Kafka, you'd have both the service and the storage on the same machine, and that would cause a lot of issues wherein if you needed to do more computation, you'd have to add more brokers. And if you had to start adding more storage, you need to change your replication factor. adding new broker to Kafka is a major operational headache. Versus Pulsar, you can do them independently. So does anyone have any questions about this screen so far? Strictly this screen.
Yes, just a second. First question, or quite opposite, last question from Vemal. In Pulsar, messages are baked up and restored using snapshots?
I don't know about snapshots. So it's an append-only log. So what that means is messages are written to the end of a log, and your messages will read from the beginning of the log to the end of the log, or the last place they are. So there's not really a paradigm of snapshots. All the messages in Pulsar are on a TTL, meaning they have a time to live of, say, a certain amount of time, but they're really deleted after you've already read the message after a certain amount of time. So that's kind of something we'll cover in the next lab, messaging dynamics, TTLs, all these kind of things. But for now, I hope I answered your question, but snapshotting is a database concept that doesn't really apply to an append-only log.
Yeah, makes sense. Next one, well, I guess I know the answer. Is the communication between brokers and bookkeepers, Zookeeper, is secured as well?
Yes, yes.
Yeah.
So you can have everything talking over TLS. You can do encryption, authentication. You know, it's pretty fun. It's
Yep.
not that hard. And the Helm charts cover all of that, by the way. So you don't have to learn TLS. You can just run the Helm charts and they'll do it for you.
As long as you have Kubernetes, but yes. But I mean, in general, Apache Pulsar is enterprise level solution. So of course, all kind of security, encrypting and so on is supported. So there is no doubt. I can simply answer yes. And pum, 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 pum. I'm not sure I got it, but there is a question from one of our most persistent attendees from United States. Kafka segments became Bookie Ledger or vice versa?
It's tricky, right? Because Kafka is different. I think entries would be segments in Kafka. So basically, I would look at, fragments as being like, so ledgers are entries. So Kafka, you define partitions at the beginning. Ledgers are created as the data comes. So, depending upon the configuration of your Pulsar topic, you can give it a number of partitions, but that's a logical thing on the broker side. We can take this conversation offline and get back to you, but that's an interesting question.
Yep. And last one, I think you will like that. How Cassandra and Pulsar fits and advantages together?
Yeah, so the biggest thing about Pulsar and Cassandra and why I love them together so much is the fact that both Pulsar and Cassandra are worldwide open source solutions. What this means is you send a message once to Pulsar or Cassandra, it can be replicated worldwide to multiple data centers. They're both distributed processing systems, they're both highly reliable, and they're both very interesting as well. So imagine running a stream on a worldwide data set stored permanently on a worldwide database of Cassandra. That's kind of the vision there. And then being able to run GraphQLs on both systems. So it's pretty fun.
Yeah, that's a lot of fun indeed. Cool. So I think we are done with the questions at this moment. We can move on.
Wonderful, thank you. So the next thing is the Pulsar proxy. So the Pulsar proxy is your own internal gateway. This basically means that when you want to talk to a Pulsar cluster, generally it'll go through a DNS entry point. And this is why Pulsar is designed to work on Kubernetes out of the gate, so it has like service discovery built into it. Next is Pulsar schema. So Pulsar has a built-in schema registry. Now this is very much like Kafka, so you can do Avro, JSON, or protobuf. You can do schema evolution, and it's backwards compatible. And schema management is automatic, and it can also be manual. Keep this schema in your mind. We may have a question about it later. Next is Pulsar functions. So the wonderful thing about Pulsar is you can actually upload your code to the brokers, and then your code will run as kind of as an AWS Lambda on the servers itself. So if you need to create an application as a service, on the Pulsar platform, you don't need to deploy a machine. You can just put it directly on your brokers and then add more brokers as you need to run more functions. So that's kind of like the major benefit of separating the storage and compute layer. Since you're separating the storage and compute layer, you can just add more compute to handle more functions. And these functions can be in languages like Java, Python, and Go. So this is very good for complex event processing, streaming, doing data filtering. So we get an input of messages and we do output logs and topic logs. We'll try and cover some of this in the very next session. So maybe we'll write a Pulsar function together.
We should.
Or
We should. I believe it's one of the most interesting chances. So we must write something next week.
oh yeah, it'll be very fun. Don't worry, don't worry. Next is the
Oh, so sorry. Can you get back to the previous slide for a second? I want to add the thing. So regarding the Pulsar functions, it's a powerful feature. It's a great feature which can really help you building flexible, powerful applications and so on. But there is a thing I want to warn our attendees because with this, how easy it's supported, how easy you can add some of the processing. You also should do no mistake like bringing parts of your business logic into that. I've seen so many companies, what happened to them, they're putting part of their business logic into database triggers.
yeah.
And then after some years, they stuck into the situation, half of the business logics in the database triggers, half of a business logic in the applications, now spread it into multiple servers. And at this moment, no one understands how this shit works. Seriously, I've seen that. It's painful. It's a big problem. And to rework this system, it's really hard and extremely expensive and very dangerous. A lot of moving parts, hidden layers, and so on and so forth. So bringing something into Pulsar function, think of what exactly you're putting into that and put it under control. And by the way, we have some great questions. We can answer them now or later maybe.
Let's start answering questions at the very end because I want to make sure we cover all the main content and then we do the hands-on lab and then we should have, because we're down to 30 minutes and people are eager to get their hands on those keyboards, right?
Yep. That makes sense.
So the next thing we have to consider is the other ecosystems and components. So Pulsar has its own connectors. We actually have our own Pulsar Apache committer building a feature to run Kafka connectors directly in Pulsar, so that's pretty fun. But there are built-in connectors as well, so you can do JDBC drivers, so you can talk to like a SQL database. We have a Kafka and Cassandra CDC, change data capture connectors as well. MongoDB. You can also run Debezium on Pulsar. I haven't personally tried it, but I've seen several articles written on it as well. The next is Pulsar SQL. So basically Pulsar SQL is just PrestoDB, now called Trino. And this gives you the ability to just simply query a topic of records. It's not going to be like a real-time KSQL kind of thing, but that's okay because there's a lot of database administrators that just want to be able to query data and just get data out for analytics purposes. So this is designed strictly for the analyst type role, and you can obviously throw this onto some type of UI. The next feature is tiered storage. So with Pulsar, you have the ability to just store messages on like, a much cheaper file system, an S3 bucket, an Azure blob store, or even an HDFS database. So you can basically lower your costs exponentially by going from Kafka to Pulsar. On Kafka, again, you can't separate your storage and compute layer. So whenever you need to store more data in Kafka, you have to add more Kafka brokers. And that gets very expensive when you just need more disk drives. The tiered storage is transparent to client, and you can basically configure it on a topic level as well. Next is security. So the authentication is very pluggable. So you can do certificate-based authentication, JWT-based authentications, Kerberos or OAuth2. So authentication means there's a user that has to basically connect to the cluster. Then you have pluggable authorization, which means that you can authorize them to a topic, to a namespace for a tenant, and we'll cover those topics later. And then finally, we have TLS encryption end-to-end, both the tunnel between every aspect of Pulsar, and you also have plenty of example code on the Apache Pulsar website on what's called end-to-end encryption, where you can encrypt every individual message, or you can do, hard disk-based encryption on the operating system level as well. They're all Pulsar also has Prometheus built into its Helm charts. We prefer you to try the DataStax Helm charts, of course, but there are Helm charts available for Apache Pulsar. And it already has, alert manager built in, so you have your alert thresholds. So with our own flavor of the Helm charts, you get an administrative console, which gives you a powerful UI for reading things like, namespaces and sinks and sources and viewing functions and getting code snippets and looking at various clusters. So it's a web-based administrative tool, and it allows you to manage multiple environments, multiple tenants, multiple namespaces, and there's many administrative CLIs as well, so you can basically administer an entire Pulsar cluster from the terminal command line. Okay, so what is multi-tenancy in Pulsar? What is that all about? Why have I not really dived into it? Well, let me dive into it now. So imagine, again, you have multiple business units, right? Each of these multiple business units have different, organizations under them, and then they have their own business logic, different topics, like maybe they're doing risk, storing credit. So if you're running a worldwide cluster, like a US West in Asia, US East in Europe, these different regions, each of those clusters needs to have its own administrative layer. So you have authentication, authorizations, isolation policies, which means that you can isolate messages to be stored on one specific machine only. You can do storage quotas and distribution. So I'm just going to bring up, give me a second. Yeah. So basically, you have tenants. Let's look at something like e-payments. In e-payments, you're going to have maybe two namespaces. One for just regular payments, which will track things like credit cards and gift cards. And the payments, you want to make sure that only the payments team can see that information. It's PII data, it's PCI compliance. You have to really lock it down so no one can touch it. The next is you have another namespace for fraud detection, where you can do like some very simple algorithms to do the risk store detection. So you can really organize your data in a very hierarchical way. So this is not easy to do in other systems, and this is why Pulsar is very good for building a worldwide messaging platform. So how does georeplication work? Well, let's jump straight into it. So georeplication means is that for each tenant, so going back here, you can create tenants that span multiple regions, or you can have tenants that are isolated to a specific cluster. So that's the power and flexibility of Pulsar. You can have your tenant available in one space and a tenant available everywhere else. And that's kind of the power of it. So when you have georeplication enabled on a tenant basis or a namespace basis, when you produce a message to, let's say, a topic 1 in cluster A, that message will be replicated to cluster B and C, and then it will do an acknowledgement after the message is replicated worldwide, and then the consumer of that message can then read it, later. So it's a very reliable and simple way of doing worldwide application messaging for reliability and scale. You also have a replicated subscription, so you can keep your subscription state in sync. You have consumer failover to another cluster to resume from another failure point, and you have a sub-second delay, and you also have basically this reliable design. The other thing too is the local acknowledgement. So you can configure basically a local acknowledgement, so your acknowledgement of messages are local to a particular region. You can also enable what is called synchronous georeplication. So if you send a message in one region, you can acknowledge that it's been replicated worldwide. You also have a rack awareness policy. You can also selectively have the application go to a particular region. So, again, Pulsar is designed from the very ground up to do worldwide messaging. You also have the interesting capability of creating an active-active architecture, active standby, but you can also have one-way replication, right? So if you're doing business in China, you can never take data out of China. You can only put data in China. So that's a good use case here where, you put in some data, you have its own cluster running in there. You can also have an aggregated cluster. So if, you're maybe part of the finance team and you need to collect all your very simple compliance data, you could have like a cluster that's for financial analysis, and you can have all the data replicated to that cluster of a particular topic. So it's pretty fun what you can do with Pulsar. All right, lab time.
Yeah.
Lab time. Let's do it.
So I have a big question to our attendees. There are some questions that aren't answered yet. We will do now lab work online all together, and then we will have a quiz because we still want to send you some prizes. And after that, we may stay. Zig, do you have some time today?
I think I do.
If we will have some time, we will answer questions after the lab time, after the lab work, and after the quiz. Because first things first, we have to fit to the schedule, and then you can stay and ask some more questions. Okay? So
Good.
I will switch back to my screen. Give me a moment. And what you have to do right now is, boom. What you have to do right now is to follow this address. I will throw a link to the YouTube chat. etsx.io/enterprise streaming series. Oh, event streaming series .lab1. https. And I will throw the same link to Discord. And what's your work now is to push the button and to grab a training instance and to do it. And I will go a little bit in front of you and do the exercises on my own. So we will discuss how it goes and what do we have to do. But it's all well explained in Katacoda. And if you used Katacoda before, you might love it as I do, because Katacoda is amazing. And you can run complex software and do complex lab works without installing anything, because we installed everything for you. And that's an amazing project now supported by O'Reilly Publishers House. You may have heard of them. Yeah, I love Katacoda. It really helps us to run educational things. So in this scenario, we will install, configure and start Apache Pulsar. We will create new topic using Pulsar admin. We will create a consumer using Pulsar client. We will create a producer using Pulsar client and use Apache Pulsar for PubSub messaging. Now that's an important point. Today we work in console, okay? But in general, you use such systems not only in console. So for the next class, 1 week later, for the next workshop, we will already work with real code. But now let's start from the simple things. First thing we have to do is to install Pulsar. And that's a very easy job in our case. First thing I do is I simply download the archive of latest Pulsar version 272, sorry. And when I have to unpack it, and it will be done. So all works very well. Now take a look. If you don't have Katacoda experience before, there are two ways for you to work. First way, you can type the commands on the terminal on the right. Who am I? Root. Where am I? Apache Pulsar. Or you can simply click these dark fields on the left side and they will be executed automatically. Good. So I've just downloaded Pulsar, unpacked it, and switched to a folder, proper folder, in order to be able to execute all the commands. Now I can take a look at the command line tools I'm going to use today. I will ask to show all the commands in the bin folder. So we have multiple parts of Apache Pulsar here. Now we are going to work with the bin folder. There are commands like Pulsar admin, Pulsar client, and so on. Those we will need today. Then we have to start a local cluster using Pulsar command. So it will look like bin Pulsar standalone. Before doing that, I want to show you one thing. So you will need to know, if you want to run Pulsar locally, not in Katacoda, but doing something on your own, there are a couple of things you need to consider. Expert Pulsar. We did some pre-configuration to simplify deployment of a Pulsar, just to make things easier. And one thing what really matters here is this line. We set an environment variable, Pulsar memory, to limit it to maximum direct memory size, because in Katacoda scenarios, we may very easily run into limitation of available memory. Those are not so huge servers so far. And you may run into this problem as well. If you try to run Pulsar on your own and you get a warning like, okay, no memory available, I'm dying from Pulsar, then you know what to do. You need to set environment variable to configure available memory to it. And if you use previous versions of Java 8, 11, GTK, you may run into deprecation warning of Nescorn. We just removed it for you. Okay, so now I can launch the Pulsar here. So I can type it on my own, and just click on the left side. Bin Pulsar standalone. Boom. And now it will be a long list of different messages, because Pulsar starts in standalone mode and it still needs bookkeepers, zookeepers, and so on and so forth. So there is plenty of work to do. And it means what we can proceed. So now we will use Pulsar admin to learn about the cluster, tenants, namespaces, and topics. All the things explained by Zeke recently. So first we are going to admin terminal. Notice we have multiple terminals here on top. Main, admin, consumer, producer. We can create more if we want. Not need that right now, we have enough, but you can if you want. Let me make it a little bit bigger maybe. So I have to go to admin terminal. Here we go. I have to switch to the folder. And I will ask Pulsar admin to ask for clusters list. I will click here to execute this command. Katacoda is doing that for me. And we have only one cluster, standalone. Well, because we are running Pulsar in a standalone mode. Now we can ask the same Pulsar admin for tenants list. I'm executing this command by click, and we have two tenants, public and sample. Of course, we can create more if we need. And then finally, we can ask for Pulsar admin namespaces list for public. So we have public tenant, and in public tenant we have namespaces public default and public functions. We can ask instead of public for sample, for example. Don't be afraid to make experiments. Don't be afraid to crush things. It's Katakode, it's not your production. It's much better to break things here than on your production. So that's how you learn, and don't be afraid. Cool. And finally, I want to display topics in the public default namespace. So public stands for tenant and default stands for namespace. I click that and answer will be quite expectedly empty. We don't have any topics by default. That's a standard behavior. So I want to proceed to step 4. Jai Gaurav asks, is it run on Kubernetes? So it definitely runs in Docker. Regarding the Kubernetes, I don't know at this moment.
It runs in Kubernetes, that's for sure.
Okay.
Yeah. By default.
So answer is yes, it is Kubernetes. Cool, so let's move on. Now, we will use Pulsar client to create a consumer to subscribe for some kind of the notifications. So first I will go to consumer terminal. I will switch to my folder with Apache Pulsar, and I will subscribe consuming client consumer to the new topic using Pulsar client tool. Let's take a look on this command. First one will be Pulsar client. So that's the command we are calling. Now, what exactly we are going to do? We are going to consume. Pulsar client may execute multiple operations. You can check for that with bin Pulsar client help. And you think we missed admin terminal? You think so? Let me check. Oh, you are right. You are right. You are right. You're right. Okay. So thank you, Tanai. Thank you, Pranithar. Thank you. We indeed skipped the step 4. My bad. So we will use Pulsar admin to create a new topic. To subscribe to the topic, we need this topic, and we will create a topic in public default, call it Shakespeare quotes. It's done very easy. Pulsar admin, what? Topics, what to do? Create, and then the name of this topic. So it will be not the name, but let's say the resource locator for this topic. Persistent, public, default, Shakespeare quotes. So tenant, namespace, name of the topic. Execute. Created. No response means good response. It's still Linux in the end. And then finally, we ask for the list of topics, like we did before. Pulsar admin topics list for public default. And now in the we have this one, persistent public default Shakespeare quotes. So it's done. I already did step 5, as you've noticed, with the consumer terminal. Good thing, what my consumer stays with this topic, so nothing bad really happened. I don't have to restart that, and we can proceed to step 6. We will use a Pulsar client to create a producer what will send messages. But you know what? We are experimenting after all, so I want to make a step to the side from this list and do something more interesting. We have here one consumer running, right? Bin Pulsar client consume blah 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 my Shakespeare subscription. I want to run one more consumer terminal. And I will execute the same command there. Of course, I have to switch to Apache Pulsar soon. Okay, no, 0 messages successfully consumed, sure. We already have exclusive consumer connected. Yes, so I have to mark it as non-exclusive, but it's exclusive, so I won't have the two consumers on the same one. This one is available and here exclusive consumer is already connected. Okay, no worries, it's still here, it awaits for something. So now we have to go to the producer terminal. First, don't forget to switch to the folder. Don't be like me. And second, we will produce, with Pulsar client command, we will produce to public default Shakespeare quotes message, brevity is the soul of the wit. Okay, Katakoda doesn't like me for all the switches, but it's okay. I will just copy paste it. Okay, so something just happened. We can take a look at all the logs. There is quite a lot. But what really matters to us, in the beginning, connected to server, and in the end, one message successfully produced. Now, we can switch to consumer terminal and take a look what's happened there. As we got the consumer running, we see this got message report with the content, brevity is the soul of wit. Exactly the one we recently produced. Client closing, we are done, one message successfully consumed. In this way, notice, we executed consume for one and only one message. We may work in a little bit different way. So I will switch to the step 7, to last step, and in the producer terminal, I will send 60 messages at the rate of one message per second. So in the producer terminal, okay, I will do it again by copy paste. Usually it works. And it starts to produce messages. And as I say here, we have list messages described here, and we have a rate on 1 per second. And it looks like it works. It produces them step by step. Then in the consumer terminal, I can run Pulsar client to consume Shakespeare quotes topic from my Shakespeare subscription, number 60. In this mode, by number 60, I specify to this consumer what it has to expect 60 messages. If it will has less, like 58 for example, it will stay subscribed and wait for 2 more. If there is more messages awaiting to be consumed, it will consume 60 and quit. So I'm pushing the button and we are getting things already. So first 2 were produced recently by me, and those are getting live. Question by Tiago, can you set the consumer to consume indefinitely? Yes, of course. Sure, that's how it normally works. Yeah, and it looks like I've called it producer twice because I see a lot of duplication. That's mostly probably because I pushed the button twice. 60 messages produced successfully. Cool. Okay. Okay, yes, so indeed I've executed this command twice. That's why I have duplication here. It's on the producer side. So in short, if you produce the same message twice, it will be consumed twice because, well, it was from your side. So it is done, and we can go to consumer terminal and see all the list of the messages consumed. Now we have 60 messages successfully consumed. Question is, how many more do we have? I bet we have 60 more because, well, we just dispatched them twice. And yeah, here we go. In the end, when the second run will be executed, queue will be empty and we will be done. So that's 1955. Zik, how do you think? I think we are done with the step 7. I think we are done with the practice at my side. But you may need or you may want to have more time. That's completely fine. So this instance stays for you for some more time. In the end, don't forget to make the screenshot of the congratulations you've completed the scenario. Don't forget to make a screenshot, because you will need this screenshot to submit your homework and to get your participation certificate in the end of the workshop series. So, well, if you forgot to do it, or if you completed the work already and closed the window, don't worry, you've seen it takes, if you run through, just like 5 minutes. And we are done with this one. And I bet if I run it again, it will be empty already. Okay, so it means I've executed this one more than 2 times. Good. So, this job is done. And I kindly ask you to complete this practical step, complete this lab after the workshop, and set the scenario rating to the number, to the amount of stars you think it deserves. Personally, I like this scenario. It's a simple one, but we have 4 more lab works for you in the upcoming days, next Monday and next Monday. And finally, I think it's time to switch back to Menti.
I think it's time to do that quiz.
Yes. So let music plays, and we are going to ask questions and you are going to answer them. And if you are fast enough, if you give the right answers, you will get the prizes from DataStax. And don't forget, you have like 30 minutes or 30 seconds to jump back. Go to menti.com and use the code 65532834 if you are not in yet. And if you are not in yet but you want to join, you may also scan this QR code next to Zik or just enter the code close to me. And we are almost out of time, so please hurry up because we have to start. Once again, menti.com 65532834. I see a lot of people has joined it, and we are going to start just 10 seconds. How many people do we have on YouTube right now? I don't know how many people we have on Twitch, but on YouTube we have almost 100 people. That's amazing. Thank you. And Murat says 2 hours is not enough for this great content. Thanks all the people. Thank you so much for the warm feedback. And I'm completely agree, 2 hours is not enough. That's why we have 4 more hours. 2 next Monday and 2 more Monday after that. That really, thank you so much for the warm feedback. Yeah. Cool. So we have 53 people ready to rumble. Let's start then. So, let's start. Answer fast to get more points. Which statement is right about HTTP API calls? They are slower than asynchronous messages. They can't have payload. They are blocking synchronous. They are obsolete and discontinued. Time is up. And the right answer was the answer number 3. They are blocking. They are synchronous. They are not slower than asynchronous messages. That's important to understand. Message per se, as it is, goes exactly the same network, exactly the same time, with exactly the same payload. So message is not slow. Synchronous HTTP message is not slower than the asynchronous messages. But the time available for the producer to work with asynchronous is indeed higher, but that's a different story. So, correct answer is they are blocking synchronous. And let me see how leaderboard looks after the first question. I see Thiago is on the 3rd place, Gabriel Fournier on the 2nd, and Parfa was the fastest, earning 900 and 4 points, which is a very good result. But that was only the first question out of 8. So let's take a look how it goes in the next one. And that's a question number 2. So answer fast to get more points. Where does Pulsar store data? Apache Zookeeper, Apache Bookkeeper, Apache Kafka, in a bookstore. So, where does Pulsar stores data? Time is over. And the right answer is Apache Bookkeeper. Not in a bookstore, that's for sure. And definitely not in Apache Kafka. That would be quite funny, what do you think? Yeah, Apache Bookkeeper is used to store data. Good. So far, so good. So, who made the mistake? Who is out of top 10? Okay, looks like Tiago left the top 10, but I'm happy to greet Ivan Garcia, some familiar names, and Partha is fastest again. That's an incredible performance. That's 1,827 points. That's the best result so far. And Prakash is on the second place with approximately 50 points delay. Gabriel still holds in the top 3, which is a very good result. But we have 6 more questions, so let's advance. Question 3. Answer fast to get more points. Where does Pulsar stores metadata? Apache Kafka, Apache Bookkeeper, Apache Zookeeper, in a bookstore. You have some seconds to think about that. Then time is up. And the right answer is Apache Zookeeper. It's not Bookkeeper, it's not Apache Kafka, and it's still not a bookstore, sorry. So, looks like nearly everyone gave the right answer, and there are no mistakes from the top 10, but who was the fastest this time? Fastest was Ruby, making it into the top 10, and I see Artyom made to the top 9, and Ivan Garcia holds the 7th place. That's a very good result, but top 3, the positions what are getting prizes, are still the same: Partha, Prakash, and Gabriel Fournier. Let me take a look at the 4th question. So, answer fast to get more points. In Bookkeeper, what is a bookie? Did you pay that attention? In Bookkeeper, what is a bookie? Server with Apache Bookkeeper running, a collection of records, a hashing function, a guy who takes bets for you. Oh yeah, I would make a bet there will be a mistake, and indeed, in Bookkeeper, Bookie is a server with Apache Bookkeeper running. It's not a collection of records. And that means we are going to have a lot of mistakes on the leaderboard. So let me see the result. Oh my god, that's a vibe. That's like a real vibe. From 2nd to 6th place, all the full of the mistakes. Partha gets to the 1st place, getting not the fastest but still right answer. Nitesharam gets to the 2nd one, Lyubagov is on the 3rd one, Prakash is on the 4th, and Piotr get to the 5th place with the fastest correct answer this time, and Gabriel is only on the 6th. So let me take a look at the question number 5 and answer fast to get more points. Which subscriptions are available in Pulsar? Share it, exclusive, failover, whatever you want for $9.99 per month, available right now. Which subscriptions are available in Pulsar? And it was a quite funny question because all of them are available and any answer of first of 3 is correct. Share it, exclusive, and failover are all available in Pulsar. And no, Pulsar is an open source technology, so you don't pay to use for that. Well, you only maybe, as it's an engineers to engineers, you maybe are getting salary to run it. quite sweet for me. Yeah, all of the above should have been an option, but Menti sadly doesn't have all of the above in this mode. So, Harry was the fastest, making it to the top 10. Ivan Garcia is on the 9th place. First place holds by Partha, and if he or she will make no mistake, it's definitely will be the winner for today, because the gap now is a real thing of 900 points. That's a solid difference. So far, he did no mistake. So, question 6. Answer fast to get more points. What's the name of connectors to push messages from Pulsar to our systems? Think, source, sync, seek. So many options. Such a short time, but most of you gave the right answer. Correct one is sync. Not source, not think, not seek, definitely not sync. So let's go. Show me the leaderboard. Okay, so competitors made pretty well. Petra Alim was fastest. That brings him to the place number 10. Partha holds the first one, with Piotr on the second and Kazi on the third. And Bala is following Kazi, fighting for the third place with just 9 points of difference. That's a competition, ladies and gentlemen. That's a real competition. So, we are almost out of time, and we are almost out of questions. So, last two, and that's question number 7. Answer fast to get more points. Which schema is not supported in Pulsar? Avro, JSON, Protobuf, or XML? Which schema is not supported? It's a hard one, but the right question again was given by most of you, but the biggest part of the attendees. XML schema is not supported. Pulsar supports Protobuf, as quite popular in these scenarios, and Avro is supported as well. XML is not supported. So, oh my god, Piotr, goodbye, see you again later. We have 2 more workshops, you can win in the next one. That was a bad answer. And Prakash and Bala gave exactly the same time answer, which brings Bala to the second place using the mistake of Piotr and brings Prakash to only 9. Partha, Bala and Kazi are holding the first, second and third place, with Tilak following very close with only 60 points difference. I can imagine how those two are nervous right now, Kazi and Bala. And Partha should make no mistake, and then she keeps the first place. Sorry, I don't know if it's a male name or female, I'm sorry. So, it's going to be the last question. So, get ready for that. Release your mind, warm up your fingers, get ready. We are starting the last question of today's quiz. The question what defines everything. Question 8. So, answer fast to get more points. Which is not a component of Pulsar vocabulary? Producer, consumer, subscription, director. Which is not a component of Pulsar vocabulary? Okay, it was too easy for you. It was too easy. Next time we will prepare some questions harder. 35 people gave the right answer, but who of them was the fastest one? Who was the fastest one? Bala was the fastest one. getting to the second place or holding second place. And that's how it looks in the end. Tilak, Ivan Garcia, Fire Dancer, Ruby, Fitra Alim, Piotr and Prakash are getting into the top 10 and they can be proudly and then KB have something to be proud for. It's a tough competition with dozens of people. Then Kazi and Bala with the fastest answer in the 8th question, getting to the second and third place, and Parfa managed to give all the right answers through all the quiz, and that brings him to the first place. And now 3 winners, Partha, Bala, Kasi. Please write a message to Jack Fryer. Jack Fryer already wrote a message in YouTube chat. Please send him a screenshot of your Menti screen with your winner position to claim your prize at the address of jack.fryer@datastacks.com. And Ivan Garcia, next time, keep fighting. Well played, everyone. It was a really good one. I have enjoyed any moment. It was like you took it seriously, I see. Good. Now, before you close Menti, let me ask you one final question in Menti. Quiz is over, so no prizes for this one, but we will really appreciate your feedback. What did you like the most in this workshop? If you liked something, I hope so. What would you improve? What would be any feedback? Or actually, it's an open question. So if you think you want to learn something on a different topic, let me know. Oh, yes. And thank you for highlighting that we are not getting the swag since 3+ months. Sorry. We got a serious problem with a logistics company we were partnering with. And now we're finally dispatching prizes using different logistics company. So swag will be dispatched or maybe already delivered very soon. Jack, if you could please let us know in the YouTube chat what's going on with the swag. It would be really great. Thank you. More practice opportunities. It comes. So this one was more about theory and we have more lab works coming into the next week. Would like to see more use cases. Okay, I see them. Pulsar Arc needs easier explaining. Well, man, Pulsar architecture and Pulsar is a solution what is able to dispatch billions and billions and billions of messages all across the world. Sorry, but such solutions cannot be simple. It's just you cannot blame your bicycle what it cannot move 40,000 kilograms of some stuff because your bicycle is a bad fit for that. But also you cannot be too sad about the airplane, superplane Boeing, what it's hard to manage. Yes, it's hard to manage because it's an airplane able to lift dozens metric tons of goods. So of course. Well prepared lab, thank you. All was new for me, got some idea, 2 hours well spent, thank you. Okay, I thought volume was well balanced, thank you for the feedback, I will take care of the volume better next week. Good to know. Press to querying examples, that's interesting. Team interaction and the way content build up, of course, Menti, great content, good session, and so on and so forth. Thank you. Thank you too. We can have some example of problem solving scenario using Pulsar. Something like making purchase order on Amazon, how it works through the system. That's a great question, by the way. For the next week, we have to prepare some better explanation on the use case, on how exactly it works. Thank you so much. And we are done. So, few last things. Next episode, June 14th, same time. Subscribe right now. Please notice what different episodes of this workshop series require separate registration, so you have to register again for the next episode. I'm sorry for the inconvenience, but yeah, we need that. Sorry. Next one will be Pulsar in action. So we are getting into more advanced things with Pulsar. Zik, could you please explain what's the things we are going to do next week?
Yeah, so next week we'll be covering, producing and consuming and messaging and design patterns using Pulsar. So we'll be doing more hands-on keyboard exercises, how you should use Pulsar as an application developer, and it will be, yeah, that's pretty much it. So it'll be like hands down on keyboard kind of stuff.
Okay, I see Bala Narasimha reports the registration is saying sales ended. We will check that. That should work. So give me a moment. datastax.io/kss-ep2. But registration must be, if it's closed at the moment, we will reopen it because that's obviously a mistake. But for me, registration looks open. So yeah, it looks good to me. Tiago, if you registered for session 2 yesterday, then you are good, of course. Okay, so Jack fixed the registration. Registration is opened again. That's good. Now, if you like our workshops and if you don't want to wait for a full week, well, thank you. We have something basically on Wednesday and second run on Thursday. So on 9th and 10th of June, build a Netflix clone with GraphQL, React, and NoSQL database. Led by Cedric, Ryan, and me on Thursday. So on Wednesday and Thursday, it's the same content, but different speakers and different time zone. And actually, let me send you a link into the YouTube chat so you would be able to register if you are interested in that. Okay, it's being opened, so register. Nope, wrong button, sorry. Sorry for a little delay. That's it. I got the link finally. So I'm sending it to the YouTube chat. Oh, Jack Fryer already did that. Hey Jack, you are a big guy here. Okay, basically that makes today's workshop. We are out of time, so I think we are done. If you want to communicate further, if you want to ask more questions, if you want to extend your knowledge on this one, come next Monday. And don't forget to catch us on our Discord server. Discord server link is specified in the description of the video. But I again will paste the link. So jump into our huge Discord server and let's talk them. You did amazing job today. But what I really want to say, thank you to Zach Dean, because this workshop was mostly prepared by him. And it's an incredible work, and I'm happy to have it running here. And thank you so much for joining us today, answering all the questions and making all the presentation. That's an incredible thing. Thank you.
Thank you, everyone, for participating today.
Cool. So see you soon, and hopefully to see you Wednesday and Thursday. And a little bit of music for you to enjoy and relax in the end of the workshop. And don't forget to do your homework and complete the lab 1. See you later.